Hello students, today we are taking a topic called conductometric titrations and their curves. What is a conductometric titration and what is its curve? Generally in the titrations, end point is determined by using the either external indicator or internal indicator or an self indicator. But in a conductometric titration, the end point is determined by using the conductance. By using the conductance, end point is determined. Those titrations are called conductometric titrations. Before to know the conductometric titration, students have to know about the terminology for this topic. One is called endpoint, another one is called titer solution, ionic mobility and ionic conductance, and spectator ion. Yes, what is called an endpoint? Where the equivalence of one reactant is equal to the another reactant in a given titration is called as the endpoint. What is a titer solution? For the better understanding, the solution which is taken in the burette or in the titration which is added as the time goes on is called titer solution. Ionic conductance or ionic mobility, of course they have technically different definitions. Here we considered the speed of the ion. More is the conductance or more is the mobility, more is the speed of the ion. And next one, spectator ion. An ion which is present before the reaction and after the reaction can be considered as the spectator ion. For the sake of convenience, I am taking an NaOH. It reacts with the HCl. Suppose the solution contains H plus and Cl minus. To this, if I am adding NaOH, after the reaction, the products are Na plus, Cl minus plus water. If you observe, before the reaction, Cl minus ion are there. After the reaction, Cl minus ion is there. Those ions are called spectator ions. What is the significance of the conductometric titrations? Number one, you are getting accurate endpoints. Endpoints by the conductometric titration. Endpoints will be accurate. And easy to determine endpoint where endpoint is not possible to get. For example, weak acid plus weak base. The end point is not at all sharp, it is not possible to get by the normal volumetric titrations. In those, it gives the accurate endpoints. Third point, minimum amount of reactants or the products, reactants or the titrant and titers are consumed in the conductometric titrations. So minimum amounts of the material is utilized. So these are the significance of the conductometric titrations. Now, how many types of conductometric curves here possible? Take a look. So I am classifying here into 6 types. If you made a titration between strong acid versus strong base, strong acid versus weak base, weak acid versus strong base, weak acid versus weak base, a mixture of stronger acid, weak acid versus strong base, and in the precipitation reactions. Now we enter into the discussion of every curve. Each curve of all these 6, I am taking the first one. Yes. Strong acid versus strong base I am taking. How this curve will obtain? How can we determine that curve, that given curve is for HCl and NaOH or for the strong acid and strong base? For this point, student have to memorize one important point. Here conductance is due to the ions. Here conductance is due to the ions. You have to remember H plus ion mobility is greater than the Na plus. This is the key point for this conductometric titration. H plus has the small size, Na plus has the high size. So H plus under the influence of electricity will move slowly, right? Taking one by one. HCl. Here NaOH is the titer. That means it is collected from the burette. So as the experiment going on, as the time going on, NaOH is added to the HCl solution. After the reaction, because of addition of NaOH to the HCl, the products are NaCl and water. NaCl and water. Right? HCl is taken in the conical flask. It contains H plus and Cl minus. To this we are adding NaOH. That means to the system containing H plus and Cl minus, because of neutralization, you are getting Na plus Cl minus plus water. If you observe keenly, H plus ion and Cl minus ion in the given system changes into Na plus and Cl minus. Cl minus is the spectator ion because before the titration and after the titration it will be there. So finally H plus is replaced by the Na plus. So in this titration H plus is replaced by the Na plus. That means suppose HCl is a stronger acid. HCl is a stronger acid. It has the conductance high. Right? Suppose this is the conductance of the HCl. That point represents conductance of the HCl. If NaOH is added continuously, all the H plus ions are replaced by the Na plus. The mobility of the H plus is greater than Na plus. That means the incoming ion Na plus has lower conductance than the H plus. As a result, the conductance of the given solution will decrease. This decrease is continuous until all the HCl is consumed, and then there is an abrupt change in the trend. So this is the point, represents end point. Until the end point, here the conductance decrease is noticed. That means titration is going on because H plus are replaced by Na plus. After the complete neutralization of the given equivalents of the acid, if you continuously add the NaOH, then it starts to increase due to the formation of more number of Na plus and OH minus. So this is the curve for stronger acid and stronger base. Right? Taking one more example for one more type. Now I am taking stronger acid versus weak base. Strong acid versus weak base. Look at this. Stronger acid versus weak base. Here the strong acid is the HCl and the strong base is the NH4OH. Right? Here also NH4OH is the tighter. That means continuously I am adding NH4OH from the burette into the conical flask in the experiment. For the sake of convenience, I am using the words conical flask and the burette. Right? This solution basically contains H plus and Cl minus. Right? To this we are adding NH4OH. So that means the system initially contains H plus and Cl minus. Because of titration, because of the neutralization reaction, NH4Cl minus ions are formed plus H2O. It will not conduct the electricity. NH4OH is a weak base. So overall the conductance is due to the H plus Cl minus. It will be converted into NH4 plus Cl minus. Right? If you observe, the system contains Cl minus initially. Since NH4Cl is a salt, it completely ionizes and forms the Cl minus again. This is called a spectator ion. Here H plus finally changes into NH4 plus. Here the key point is mobility or conductance of H plus is greater than NH4 plus, just like in the previous case. Because of its small size, it has a higher mobility. Then, so automatically here also the conductance of the HCl will decrease on adding the base. Conductance of the HCl decreases on adding the base. So this decrease will happen until the end point is reached. Suppose this point represents the end point. After that, if you add NH4OH continuously, there is no change in the conductance. There is no change in the conductance. Because NH4OH is a weak base, so there is no change in the conductance. So this is the graph for stronger acid versus weak base. In the previous case, we are getting the graph like this. Here we are getting the graph like this. So this is the graphical curve representation for the stronger acid and strong base. This is the stronger acid versus weak base. So based on the type of the curve, we can decide which titration will run which type of compounds. Taking another one. This is weak acid versus a strong base. Taking weak acid versus strong base, here the weak acid I am taken CH3COOH. So generally what is the reaction is going on between these? CH3COO minus plus Na plus water. Weak acid, acetic acid is a weak acid. Because of its poor ionization in the graph, its conductance point will represent nearer to the 0. Because of titration, a weak ionized CH3COOH because of titration or because of neutralization will changes into CH3COO minus and Na plus. That means a system with very less number of ions or negligible ions will changes to completely ions. In the aqueous solution, more is the number of ions, more will be the conductance. So here conductance continuously increases until the end point, because acetic acid is converted into acetate ion and Na plus. After reaching the end point, that means where the total equivalents of acid is consumed, the graph will increase, or the graph will take a steep line, steep curve. What is the reason? Here you are continuously adding the NaOH. NaOH is a strong base. Initially you have the acetate ion and Na plus before reaching the end point. After reaching the end point, so Na plus and OH minus number will increase. OH minus has more mobility than acetate ion, so such a graphical steep will be represented. This is the curve for weak acid and the strong base. Right? So here graphical line is represented like this. An increase and an abrupt steep increase. This is for weak acid and strong base. Yes, students, now I am taking weak acid versus weak base. Here titer is NH4OH. That means I am adding NH4OH solution to the CH3COOH. This CH3COOH is a weak acid. It has no ions. Because of its weak ionization, very less number of ions are there. NH4OH is a weak base. It also have very less number of ions. That means the conductance of the CH3COOH is very less. On the y coordinate I am representing at nearer to the 0. It represents lower conductance. To the CH3COOH, I am adding to the system of CH3COOH, I am adding NH4OH. What happens? Salt is formed, CH3COO minus plus NH4 plus. Salts are always in the ionic form in the aqueous solution, and water. This is the system changed from acetic acid to acetate ion. Initially we have CH3COOH, a poor electrolyte. Because of titration, so CH3COO minus and NH4 plus ions will form. CH3COO plus minus and NH4 plus ions will form. Right? That means a weak electrolyte is converted into strong electrolyte. So if NH4OH is added continuously, the conductance will increase due to the formation of these ions. This will happen until the consumption of total acetic acid. So acetic acid is a weak acid. It has lower conductance. As that NH4OH is added continuously, its conductance continuously increases. After reaching the end point, it will be almost constant. So this point where the conductance change will change with the NH4OH is considered as the end point. Right? So this is the curve obtained for this one. This is the curve. This is the curve. So a increase up to end point and will be normal. after adding the NaH4OH. This is the curve for weak acid versus. Students, here I am taking mixture of weak acid and strong acid. It is used for the titration of against the strong base. Here I am taking weak acid and HCl. So it is taken as a mixer. To this NaOH is added. That means titration of mixture of weak acid, strong acid versus strong base. What happens here? Students, take a look. Here this mixture contains H plus, Cl minus and CH3COOH. These are the species present in the conical flask initially. To this you are adding the NaOH. What happens? NaOH is a stronger base. It readily reacts with the where the H plus ions are there. It never touches the acetic acid. Because acetic acid is a weak acid, it takes some time to ionize. But here H plus is ready. So NaOH react with the H plus of the HCl. So in the first step, you are getting CH3 COOH plus Na plus Cl minus plus water. That means initially we have the ions H plus Cl minus acetic acid. Because of the first neutralization, acetic acid will remain, Cl minus will remain, and H plus is replaced by the Na plus. Already you know that the point H plus conductance is greater than Cl minus conductance. Na plus conductance. Right? So that means a high speed cation is replaced by the low speed cation in the first titration before reaching the first end point. As a result, because of HCl, conductance is represented here because of its higher conductance. So that slowly it will decrease. Then now you have CH3, COOH, and all the HCl is consumed. To that you are going to add NaOH. Acetic acid is a weak electrolyte, so there is a no conductance, of course, or a weak conductance. After this one, you are getting CH3, COO minus and Na plus and water. This represents when compared with this acetic acid, number of ions will increase, so conductance will increase. This point represents the first end point, and this point also represents the equivalent conductance of the acetic acid. Now it changes to like this. Why there is an increase in the conductance? Due to the formation of Na plus CH3 COO minus ions. Right? After reaching the second end point, that means the conductance increased until all the acetic acid is consumed. Then there is a great increase due to the addition of NaOH. Further, NaOH has Na plus and OH minus. So a decrease, a slight increase, a great increase. This is the graphical representation for the mixture of weak acid, strong acid versus strong base. And finally, we have taken precipitation forming titrations. Students, Here AgNO3 is an electrolyte because it is composed of Ag plus and NO3 minus, right? AgNO3 when treated with the AgCl, generally the products are AgCl precipitate, and KNO3 is the another compound. This is the reaction takes place. Initially, before adding the titer, Ag plus and NO3 minus ions are formed. After addition of the KCl, we have AgCl and KNO3. AgCl is a electrolyte, is a precipitate. It will never cause the conductance. You have KNO3. So what are the ions present? K plus and NO3 minus. So before and after NO3 minus ion is there. So it can be considered as spectator ion. Net resultant is Ag plus ion is converted into K plus, or Ag plus ions in the solution are replaced by the K plus. Key point for this is conductance of Ag plus is approximately equal to conductance of K plus. This is the key point. Conductance of Ag plus and K plus is approximately same. Then which type of graph is represented? AgNO3 is a salt and a strong electrolyte, so it has a good conductance, right? On adding the KCl to the AgNO3, the net reaction represents Ag plus replaced by the K plus, but Ag plus and K plus have almost equal conductance, so graphical line is almost parallel to the x coordinate. After the complete consumption of AgNO3, that means after reaching the end point, the conductance will increase. Why the conductance will increase? Because you are adding KCl. It is a stronger electrolyte. So if you are continuously adding the Ag, K plus and Cl minus, conductance continuously increases. So here a graph is simply represented like this. This is the way of representation. This is all about conductometric titrations and their curves. Students, if you are liked my videos, thank you very much. And I am requesting you, please share and subscribe and like my videos. Thank you very much for watching my videos.